Hello friends, hope you all are doing good. Today we will study about a very basic but important concept of class 12 chemistry, that is the electron affinity. What is an electron affinity? Actually, when an electron is added to any neutral isolated gaseous atom, the energy released is called the electron affinity. Actually, when an electron is added to any neutral atom, some amount of energy is always released. This energy is the electron affinity and its unit is electron volt per atom or kilojoule per mole. Now let's try to understand this. Suppose this is a nucleus and around this nucleus there is an orbit and it is the electron present in the orbit. When some electron approaches towards this nucleus, the nuclear charge attracts this electron, but the electron already present in the orbit tries to repel it. So there it feels the force of attraction and force of repulsion. As a result, the atom releases some energy in order to accept that upcoming electron. This released energy is called the electron affinity. When any isolated atom, example Ag, receives an electron, it becomes an anion and the energy released is equal to 8 electron volt. This energy released by the atom is called its electron affinity. As it is the first energy, so let it be Ea or electron affinity first. This first electron affinity is generally positive because energy is generally released during this process. Now, if this anion again receives an electron or any electron come closer to this anion, it feels a repulsion force because same energy repels each other. In this case, we have to give energy from outside, and this energy, let it be electron affinity second, is always negative because we have to give some energy from the outside. So we can write like this. This is the anion. When electron is added to it, it becomes A2 minus and the energy given at this moment is electron affinity second and it is always negative. In the same way, if this A2 minus is given an additional electron, it becomes A3 minus and energy given will be electron affinity 3 and this will always be negative because we are giving energy from the outside. Please note that the first electron affinity is always positive, but electron affinity 2 or 3 is negative because we have to give some energy from the outside. So this is negative. One more important point is this: since electron gain enthalpy or delta Heg, which is electron gain enthalpy, is generally written with opposite sign to electron affinity, we can write this as minus delta Heg first for the first electron affinity. So let's see some factors which affects the electron affinity. First is atomic size. If the size of the atom is more, the coming electron will be far from the nucleus. Let's see, if this is the nucleus, and let's see, this is a bigger atom, the size is more. So when the electron comes closer to this nucleus, there will be a distance, and due to distance the nucleus will not attract the electron effectively. So energy released will be very less. So in this case we can say that electron affinity is inversely proportional to the atomic size. If the size is more, if the atomic size is more, electron affinity will be less, and if the atomic size is less, electron affinity will be more. So in this way we can say that electron affinity is inversely proportional to the atomic size. The second factor is nuclear charge. Actually, nuclear charge means the number of protons in the nucleus. If there is more nuclear charge, that means more proton inside the nucleus, it will attract the upcoming electron with more force. So electron affinity will be high. So in this case we can say that electron affinity is directly proportional to the nuclear charge. It is directly proportional. That means if Z is high, if the number of proton is high, the electron affinity will be high. Next important factor is the electronic configuration of the atom. It is observed that stable electronic configuration generally has very less or no tendency to attract electrons, so its electron affinity will be very less or zero. Example, for P3, D5, these are half-filled orbitals, and P6 and D10 orbitals which are full-filled one. So these orbitals are more stable because it is more stable. So electron affinity will be very less or nearly zero because it will show no tendency to attract some additional electrons. Now let's see some general trends regarding electron affinity. The first is along a period. So when we move from left to right along a period, nuclear charge increases, and as a result electron affinity will also increases. As a result, electron affinity also increases. But when we move from up to down any group, the number of shell increases because atomic size also increases, and the distance between the nucleus and the electron increases. So nucleus does not attract with great force and electron affinity decreases. So we have to understand this. Along a period from left to right, electron affinity increases, and from up to down, electron affinity decreases. Now let's try to solve a very important question given here. The question is, arrange all elements of period 2 in order of their electron affinity. So I have written all the elements of period second. The first is lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Now as we have just seen that from left to right, when we move along a period, electron affinity increases because the nuclear charge also increases. But in this case, let's see what can be the So let's see the expected trend. Expected trend. As we have just seen that from left to right along a period, the electron affinity increases because the nuclear charge also increases. Nuclear charge increases. So the expected trend should be lithium, then beryllium, then boron, then carbon, nitrogen, oxygen, fluorine and neon. So it will be from left to right, the electron affinity should increase. But actually the case is not so easy here. As we know, neon is an inert gas having 10 electrons. So the electronic configuration is 2p6 like this. So since the orbitals are fulfilled, there is no need to accept electron. So electron affinity should be 0 or very less. So we should write neon at first. Second, when we observe beryllium with atomic number 4, electronic configuration 1s2, 2s2, here the 2p orbital is fulfilled. The 2p orbital is fulfilled, which is a stable configuration. Stable configuration. So in this case, due to its stability, beryllium also has less tendency to accept electron. So here also electron affinity is very less or nearly 0. Now in case of nitrogen with atomic number 7, here 1s2, 2s2 and 2p3. Here 2p orbital is half filled because in all three orbitals of 2p there is one electron each. So it is a completely half filled structure, which is again a stable configuration. So its electronic affinity or electron affinity is also less. But as there is some space here, since in nitrogen there is space for extra 3 electrons, so it has a tendency to accept electron. So its electron affinity is more than beryllium. So with this data we can write the expected order like this: neon, as it is inert and has no tendency to accept electron, so its electron affinity is the least one. Then beryllium, which is stable and it also has a very less electron affinity. Then nitrogen. After nitrogen, the other elements are lithium, then boron, then carbon, then oxygen and fluorine. So our new order should be like this, but still we can see there is an exception. The electron affinity of lithium is more than the boron, because when an electron is added to lithium, it fills the s subshell. It fills the s subshell, which is close to the nucleus, and it is very strongly attracted towards the nucleus. Due to this, it releases more energy to attain a stable configuration. That is why lithium will have more electron affinity. Its electron affinity is more. But in case of boron, the electrons are filled in 2p orbitals, and its size is little bit larger than the 2s, so it will experience less penetration effect. So the electron affinity electron affinity of boron is less than lithium. So the final order, so the order will be neon less than beryllium less than nitrogen less than boron less than lithium less than carbon, then oxygen and fluorine. So with this, neon with the minimum electron affinity, whereas fluorine with maximum electron affinity. So in this way we get the final order in terms of electron affinity. Let's see one more important question. Here we have to find out the electron affinity order of halogen group. Now as we know, when we move from up to down, the electron affinity decreases. Electron affinity also decreases. So our expected order should be fluorine with maximum electron affinity, then chlorine, then bromine and iodine with least electron affinity. But the actual order of halogen group in terms of electron affinity is chlorine with maximum electron affinity, followed by fluorine, then bromine and iodine with least electron affinity. Here we see a variation in terms of chlorine and fluorine. Let's try to understand this. Actually, the electron affinity of fluorine is less than that of chlorine because it has very small size. Fluorine atom has very small size. When any electron is added to the valence shell of fluorine, it experiences a strong electron repulsion. It experiences strong electron repulsion. As a result, low energy is released, and due to this the electron affinity of fluorine is lower than that of chlorine. In case of chlorine atom, the electronic configuration of chlorine is 3s2 3p5. Since these 7 electrons are present in 3p subshell, and 3p subshell is relatively larger than the 2p subshell, so it readily accepts the extra electron. So the electron affinity of chlorine is less. So our order is like this: chlorine with maximum electron affinity, then fluorine, then bromine and then iodine.